All right, welcome back. First lesson of the new year. Let's get into it here. So today we're going to work on radicals, and hopefully a lot of you remember this stuff from algebra, but we're going to deal with radicals in the second semester, so it's a good start just to kind of get some algebra review and remind ourselves how to solve radicals. So first thing is we're going to take square roots of numbers. So sometimes you want to make some trees, kind of like factor trees when you would factor numbers. And what you're looking for when you're simplifying is you're looking for perfect squares. If you can figure out a perfect square that goes into a number, that's helpful. And another way to do it, though, is also just to kind of create pairs of numbers. And when you create pairs, you can bring them out. So I'll show you a couple ways you can go about doing it. So the first way would be if you know a perfect square that goes into it, is to find that first. So 50, a perfect square that goes into 50 is 25. So I said 50 is radical 25 times radical 2, because radical 25 times radical 2 is radical 50. Now radical 25 is 5. I can't simplify radical 2 anymore, so in the simplest form, this would be 5 radical 2. Okay? Another way is say you don't know a perfect square that goes into it. Just find numbers that multiply. So 50, I'm like, I don't know a perfect square. I could also say, okay, this is 5 times 10, right? So it's radical 5 times radical 10. And now I can keep going down. 10 is radical 5 times radical 2, okay? So now I'm in my lowest possible form, and then whenever you get it into the lowest possible form, you try to find pairs. So if I have 2 radical 5s, radical 5 times radical 5 turns into a whole number. So all of a sudden, that becomes a 5, and I'm left with radical 2, and I could also do it that way. Okay, so we'll do this next one. I'll do it a couple different ways again. And then I'm going to stick with my perfect square method. So the long way would be just to break it down into the simplest terms. So 72, that would be 36 times 2. And some of you are like, 36 is a perfect square. You can go. But I'm just going to break it to the lowest possible thing. 36 is 9 and 4. All right, and I keep this radical 2 there. 9 is 3 and 3. 4 is 2 and 2. I bring this down. So radical 72 at the lowest form would be radical 3 times radical 3 times radical 2 times radical 2 times radical 2. So what you do is you find pairs. And whenever you have a pair, you can bring out that whole number. So I have a pair of 3s, a pair of 2s, and I'm left with one extra radical 2. So this turns into 3 times 2 times radical 2, which would then be 6 radical 2, okay? If you just did it the perfect square method, you would say that's radical 36 times radical 2. The square root of 36 is 6. I'm left with a radical 2, and I can be done. So the perfect square method, if you're good with perfect squares, is a lot quicker, but you can break it to the simplest form and find pairs as well. All right, so here is another one. If I go to the simplest form, 180 is 36 times 5. 36 is 6, and I'm left with a radical 5 because I can't simplify that. So that's just your answer. All right, if you want to pause it here, and well, you already did this 180, so we'll go on. Pause it here and try to get that one. This one is 49 and 3. 49 is 7. I'm left with a 3, and I'm done. Good old radicals. All right, adding or subtracting radicals. So here you need to make sure that whatever number's under the radical, it has to be the same in order to add or subtract them. So what we do is we simplify each one separately, and then we'll find at the end it's going to be the same number, and then we'll be good. So this one, if I represent this, since that has a 2 in front, keep that in front. And then 36 is radical 16 times radical 2. Radical 16 turns into radical 4, and I'm left with a radical 2. So this is 8 radical 2. Okay, remember, you're always just multiplying and cross within each one. 98 is 49 and 2. So 49 is 7, and I'm left with a radical 2. All right, so when I simplified these, I'm now at 8 rad 2 plus 7 rad 2. So whenever you do that, you just add the numbers in front and keep the radical the same when you're adding 2. Think of the radicals as a variable. It'd be like 8x plus 7x, that's 15x. Here, x is just radical 2. So you're just adding the number in front. Okay? All right, let's do the next one. Don't forget this negative sign now, okay? So I have negative 48. That can be radical 16 times radical 3. Okay? And this comes out to a 4. And I'm left with radical 3. So that's negative 4 radical 3. So this becomes 2 times radical 9 times radical 3. So that 2 times 9 times radical 3. So this is 6 radical 3 there. So I have negative 4 radical 3 plus 6 radical 3. That's going to equal 2 radical 3. All right. All right, pause it here if you want to try to do this one on your own, and then I'm going to walk through it right now. So this is 5 radical 16 times radical 2. So this is 5 times 4 times radical 2. This is 36 times radical 2, so 36 and 2. 36 turns into 6 times radical 2. Sorry, that radical 2 is so ugly. All right, and then I'm adding these. So this is going to be 20 radical 2, because 5 times 4 is 20, plus 6 radical 2. So 20 plus 6 would be 26 radical 2. Now we're square root multiplication. So with square root multiplication, what I like to think about, I think about this as the second step. So it's like there's already a bigger number in front of me, and now I'm already broken it down into 50 and 18. So here you can combine terms if you need to. So if there's like a 3 in one and a radical 3 in the other, you can combine those and bring a 3 out. So here, this next step is going to be 2. This is radical 25 times radical 2. This is radical 9 times radical 3, okay? So this turns into 2 times 5 times radical 2 times 3 times radical 3. So now I have 2 radicals that are in simplest form. And since they're different numbers, you can't take anything out of them. So when you multiply all this, 2 times 5 is 10. 10 times 3 is 30. And then I leave and multiply the numbers in the radicals. So 2 and 3 is 6. So the simplest form would be 30 radical 6. And you can't simplify radical 6 anymore because it's just a 2 and a 3. That's in its simplest form. There's no perfect squares that go into 6. Okay? All right, let's do this one over here. 24. This is 4 and 6 times 3 times 36 could be 16 and 6, right? So 4 is done, so that's a 2. 6 is going to be radical 2 times radical 3. Bring down this 3. 16 turns into 4, and this 6 turns into radical 2 times radical 3. Okay? Now, I have a 2 here and a 2 there, so that can turn into a 2. And I have a 3 here and a 3 there. So I can pull out those 2. So I'm going to pull out this 2. I'm going to pull out this 3. And I still have a 3 and a 4. So make sure you don't lose any numbers. So look at the end of this, I no longer have any radicals. All right? This is all just going to be numbers multiplied. So 4 times 3 is 12. 12 times 3 is 36. 36 times 2 is 72. 72 times 2 is 144. What a fun problem. All right, next one. Also, in the previous one, you could have looked above. When you had the 2 radical 6s, you could have circled those instead of going simpler all the way to 2s and 3s. All right. 2. 9 times 5. 36 and 2. Okay. 2 times 3. Square root of 9 is 3. This stays a radical 5. This turns into 6. This stays a radical 2. So multiply the whole numbers first. 2 times 3 is 6. 6 times 6 is 36. multiply what's in the radical. 5 times 2 is 10, so radical 10. And that's it's in its simplest form. 36 rad 10. There's no perfect squares that go into 10, so you leave it as such. All right, next one here. 2 times 4 and 3. This is 3 and 25. 2 turns into 2. 4 turns into 2. Now what's interesting is I have 2 radical 3's. So those can turn into a 3 because radical 3 times radical 3 is 3 and radical 25 is 5. So again, I got rid of all my radicals here. So this is 2 times 3 times 5 or 60. And that's that. All right, last one, rationalizing denominators. So when we rationalize denominators, what you do is the rule in math is you cannot have a radical in the denominator. So when you have that, whatever radical that is, you're going to multiply it by it over itself as a fraction. So what it means is I have radical 3 in this denominator. So I'm going to multiply this by radical 3 over radical 3. Okay? So when I do that, this becomes 10 radical 3 over 3, and I'm done. All right. So this one's radical 14 and radical 21. It's easier to simplify this before you do. So radical 14 is radical 2 times radical 7, right? And this is radical 3 times radical 7. So since they both have the radical 7's, you can cross that out. So now what I'm simplifying is radical 2 over radical 3. All right? So I have to multiply this by radical 3 over radical 3. Okay? And now the top becomes radical 6, and the bottom becomes 3. Because radical 2 times radical 3 is radical 6, and radical 3 times radical 3 is just positive 3. Okay? So this one here is the same idea. This is going to be radical 5 times radical 7. You see that they're both going to have a radical 7 in it, times radical 7. Those cancel, so we're going to be simplifying radical 5 over radical 3. If we simplify the fraction first. So we multiply this by radical 3 over radical 3. And when you multiply across, you get radical 15 over 3. Because 5 times 3 is 15. And there's no perfect squares that goes into radical 15, so that's the radical in its simplest form. And that's it. All right, hopefully we all remember how to deal with radicals now.